Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2018, paper 6, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another OCR GCSE Mathematics past paper walkthrough. Today we're looking at the June 2018 series, and this is paper 6. You remember that papers 1, 2 and 3 are the foundation paper, and 4, 5 and 6 are the higher tier. Paper 6 is a calculator paper. So let's get cracking. Question 1. Ping chooses 4 numbers. The mode of these 4 numbers is 8, the range is 7 and the mean is 11. Find Ping's 4 numbers. Okay, so we've got some facts given to us here, which we should be able to work out what all 4 numbers are from. Let's have a look at this first fact. The mode of the 4 numbers is 8. So what does that mean? That means that there are more 8s than any other number. Okay, so there's 4 numbers altogether, so that means there must be at least 2 8s. So we could have 2 8s and 2 other numbers that were different, or we could even have 3 8s. We could even have 4 8s, but we've got at least 2. And then we've got 2 more mystery numbers to find. Okay, so that is the first fact. The second fact is that the range is 7, which means that the highest value subtract the lowest value must be 7. Now, I can't be sure what our highest and lowest is yet. I'm not sure I can use that fact just yet. I might come back to that one. Right, and then we've got the mean of our 4 numbers is 11. That one I can use straight away. If the mean of our 4 numbers is 11, that means my 4 numbers, I'm going to call that 8, 8, x and y then, because I don't know what these 2 are yet. So if I take 8 plus x plus y, if I add them up and I divide by how many I've got 4, then I know that that's equal to 11 from the fact that I've just been told the mean is 11. Okay, so cross multiplying that 4, or multiplying 4 by both sides, I'm going to get 16 plus my 2 mystery numbers is equal to 44. And then subtracting 16 from both sides, I know that my last 2 mystery numbers must be 28. So my 2 numbers must add up to 28. So I've got 8 and 8, and I've got x and y. Now, coming back to the fact that the range is 8, I already know one of my numbers, sorry, the range is 7, and I already know that one of my numbers is 8. So the very least these numbers must be, or the least possible numbers they must be 1 then, isn't it? Because 1 plus 7 is 8, so it can't be any lower than 1. Similarly, if I add 8 plus 7, I get 15. So my numbers can't be bigger than 15. So they've got to be between 1 and 15, these 2 numbers that I'm adding up. Okay, so I've got to add up 2 numbers so they're equal to 28, and they've got to be in the range of 1 to 15. So let's make y 15 for a second. If y was 15, then x is going to have to be what? 15 plus what is 28? It's got to be 13, isn't it? So it could be 13 and 15. Okay. So then I'd have 8, 8, 13, 15. That would add up to the right number, and it would have, well, it would have the right range as well, wouldn't it? Because 8 subtract 15, that works. Okay, so that seems to work. So I'm just going to put those numbers in then. So it's going to be 13 there and 15. So that's my answer then. 8, 8, 13, 15. Question 2. A box contains only red, blue and green pens. The ratio of red pens to blue pens is 5 to 9, and the ratio of blue pens to green pens is 1 to 4. Calculate the percentage of pens that are blue. Okay, so I've been given two ratios here, and they're kind of separate from each other, aren't they? So what I'm going to do first is I'm going to try and combine them into one ratio that has all three elements in it. So I've got red, and I've got blue, and I've got green, haven't I? And I know from the first statement that the ratio of red to blue is 5 to 9. So I can put a 5 in there and a 9 in there. And then from the second statement, I know that blue pens to green pens is 1 to 4. So I can put a 1 in there and a 4 in there. Okay, so notice I've got two blue numbers. I've got a 9 and a 1. Now, if I can take this second ratio, 1 to 4, and scale it up so that 1 becomes a 9, then I can kind of combine the two together. So that's what I'm going to do. I'm going to take this second ratio here, and I'm going to multiply it up by a factor of 9. And that's going to give me a ratio of blue to green of 9 to 36. Okay? And you'll see now that that 9 there matches with that 9 there. So that means I can bring down this 5 and write it in here. So I've got a kind of a super ratio now that's got all three bits included. So the ratio of red to blue to green is 5 to 9 to 36. Okay? Now we know that, we can work out the percentage of pens that are blue, because we know that there are 9 blue pens for every 5 plus 9 plus 36 pens there are. So it will be percentage blue. It's going to be that 9 divided by 5 plus 9 plus 36 made into a percentage. Okay, so what's 5 plus 9 plus 36? That is 50, isn't it? So it's 9/50ths. Well, I might just make that into 1800ths and say that's 18%. Okay. Question 3. Asher worked out 326.8 times 6.93 minus 3.4 all over 59.4. She got an answer of 19.5 correct to 3 significant figures. Write each number correct to 1 significant figure to decide if Asher's answer is reasonable. Okay, so they want us to do an estimate of this calculation and see if it's similar enough to her answer to decide whether or not her answer is correct. Okay, so let's have a look at what we've got. So on the top there, we've got 326.8. So the first significant figure is that 3 there, isn't it, which is in the hundreds column. So if we round that number off to the nearest 100, we're going to get 300. Okay, and then multiply that by open bracket. Now the first significant figure of 6.93 is the 6. That's in the units column. So rounding that number off to the nearest unit, it's going to round up, isn't it? So it's going to be 7 minus the first significant figure of 3.4 is the 3. So round off after the 3, I've got a 4, which means I need to round down. That's going to give me 3. Okay, and then we're going to divide that by the first significant figure of 59.4 is that 5. It's in the tens column. So rounding 59.4 off to the nearest 10 is going to be 60. Okay, so now we've rounded each number off to 1 significant figure. We can just go ahead and do the maths now then, can't we? So BIDMAS, brackets, indices, division and multiplication, addition, subtraction. That's the order that we're going to do things in. So you can see first off I've got brackets, which is this bit here. I'm going to do that bit first. So 300 times 7 minus 3 is 4, isn't it? Okay, all over 60. We've got no indices, so the next thing together is the division and multiplication. They have the same weighting, so we'll just do those all at once. Okay, so what's that? 300 times 400, that's 1200. And then dividing 1200 by 60, and cancel those zeros, 120 divided by 6. So that's going to be 20 then, isn't it? Okay, so we came up with an answer 20, that she got an answer 19.5. So yeah, I would say her answer is reasonable. So I'm going to say that Asher's answer is reasonable. Okay. Question 4a. Show that a to the 5 times a to the 3 all squared can be expressed as a to the 11. Okay. So let's take what we've been given to start with. A to the 5 times a to the 3 all squared. Let's just have a quick look at these brackets first. I've got a 3 on the outside, 3 on the inside of the brackets, and a 2 on the outside. That means I'm going to take a cubed and I'm going to square it, which is a cubed times a cubed, which is a to the power of 3 plus 3, which is a to the 6. Or another way of thinking about it is just multiplying that 3 and the 2 together, and that should give you a to the 6. So I'm just going to show that very clearly though, because it wants me to show it. So I'm going to say that's a to the power of 3 times 2, which is a to the 5 times a to the 6. And then when we've got two numbers with the same base, like a and a, then we're multiplying them together, then we're going to add the indices together, and the 5 and the 6 are going to get added together then, aren't we? So that's going to be a to the power of 5 plus 6, which is equal to a to the 11, isn't it? Okay, so that's that done. Write 1 over 125 times 25 to the power of 9 as a power of 5. Okay, so what we've got here then, we've got 1 over 125. Now 125 is 5 cubed, isn't it? So I can rewrite that like that to start with. And then 25 is 5 squared. So I'm going to write it as 5 squared to the power of 9. Okay. What now? Again, same as last time, I've got an index of an index here, so I can multiply those indices together. That's going to give me 5 to the 18. But on the other one, I've got 1 over 5 to the power of 3. Now that is the same as 5 to the power of negative 3, isn't it? Because it's the reciprocal of 5 over 3. So 5 to the power of negative 3 times 5 to the power of 18. And again, I've got two numbers now with the same base. So what I'm going to be doing then is adding the indices together. So I'm going to be adding negative 3 and 18 together. And that is going to give me 5 to the power of 15. Okay. Write it as a power of 5. I have. Let's move on. Question 5. The diagram shows a straight line that passes through points A and B, and a curve that passes through points P and Q. And in the diagram we can see the straight line, and we've been given the coordinates of A and B. A is 0, 2 and B is 4, 5. The curve we've been given is clearly a, well, it looks like a quadratic. It's not clearly a quadratic, but it certainly looks like one. And we've given a point on there as well, which is minus 4, 12. Right, first up we need to find the equation of the straight line. So that's going to be fairly easy to do because we've been given 2 points on the line, A and B. So we can use that firstly to find the gradient and then sub 1 in to find the intercept. So gradient first. Gradient of a line is equal to y2 minus y1 over x2 minus x1, where x1 and y1 as our x and y coordinate from the first point, and x2 and y2 are our x and y coordinates from the second point. Basically what we're doing is we're finding that change in y and that change in x, and we're dividing one by the other. Okay, so change in y first then. That y2 is going to be the y coordinate of the second point, 5, subtract the y coordinate of the first point, 2, divided by the x coordinate of the second point, 4, subtract the x coordinate of the first point, 0. Okay, so 5 subtract 2 is 3, 4 subtract 0 is 4, so our gradient then is 3/4. Okay, so now we know that, we can say that the equation of the line is of the form y is equal to mx plus c. Well, we know m now is 3/4, so we know that our line is going to be y is, so we know that y is going to be 3/4 of x plus c. Okay, now we just need to work out what c is. Now we can do that by just taking either of the points that the line passes through and subbing those two values in. I'm going to take the first one, point A. So it passes through A, which has got coordinates 0, 2. So subbing that into my equation, y is 2 is equal to 3/4 of x, which is 0, plus c. Okay, well, 3/4 of 0 is just 0. They're going to cancel it. It's going to become 0, isn't it? So I've got c then is equal to 2. Okay, so which implies that c is 2. Okay, and therefore equation of line then is going to be y is equal to 3/4 of x plus 2. Okay, so m is 3/4, c is 2, so the equation is y equals 3/4 x plus 2. Part B says the equation of the curve is y is equal to x squared plus kx plus 8, so it is a quadratic, and we need to find the value of k. Now you remember that on the graph we had a point P given which had the coordinates -4, 12. So subbing that into the equation, we should know everything other than k, shouldn't we? So let's do that then. So passes through point P, which has coordinates -4, 12. So subbing that into the equation then. So y, 12, is equal to x -4 squared plus k lots of -4 plus 8. Okay, so now we just need to go and work out what that is. So 12 is equal to -4 squared. -4 times -4 is positive 16. -4 times k is going to be -4k, and I'm going to have plus 8. Okay. So let's just collect the 16 and the 8 up together. So it's going to give me 24 minus 4k. And notice that my k is negative, so probably the easiest thing to do is to move it onto the other side of the equation, and at the same time move that 12 back over this side. You can think of it as adding 4k to both sides and subtracting 12 from both sides. And that's going to give me 4k is equal to 24 subtract 12. In other words, 4k is equal to 12. And then dividing through both sides by 4, we're going to get k is equal to 3. Okay, k is 3. Part C says Dan draws line BQ. She says triangle ABQ is isosceles. Is Diane correct? You must show your working. Okay, so coming back to the diagram, we are looking at ABQ then, aren't we? So this triangle. Okay, so that's the triangle we're looking at. Is it isosceles? So we already know the coordinates of A and B. What we don't know yet is the coordinates of Q, this point up here. But we do know that it passes, well, it's the point where the curve passes through the y-axis. So basically it's the y-intercept, isn't it? Okay, so if it's the y-intercept, it's got to be the constant on the end of the equation. So let's write down the coordinates of Q first. We know that it's lying on the line y is equal to x squared plus kx. Well, we found k to be 3, x squared plus 3x plus 8, isn't it? And we want the y-intercept, in other words, when x is 0. So when x equals 0, that's going to be equal to 0 cubed or squared plus 3 lots of 0 plus 8. In other words, y is equal to 8. And so that q then has coordinates 0, 8. Okay? So let's quickly just draw that triangle again. We've got a triangle which we're calling, so that was A, B, Q, wasn't it? And B had coordinates 4, 5, and A had coordinates 0, 2, and we now know that Q has got coordinates 0, 8. Okay, and we want to know whether or not this triangle is isosceles. Well, if it's isosceles, then two of the sides are going to have to be equal to each other, aren't they? That's the definition of what an isosceles triangle is. So we already know the side AQ, because that point there is 0, 2, and that one is 0, 8. So that side there is going to have to be 6. Okay, so if we can find AB and QB and show they're the same, either the same as each other or equal to 6, then we've shown that the triangle is isosceles. So how are we going to work out the lengths of those lines? Probably the easiest thing to do is use Pythagoras theorem. So we can say AB, side AB squared, that's going to be equal to the change in y then, 5 over 2, 5 minus 2 all squared, plus the change in x, which is 4 subtract, or 4 plus 1 all squared, isn't it? Okay, so I'm just kind of triangulating here and here. So 5 subtract 2 is this distance, and 4 subtract 0 is this distance. Okay, so then I get AB all squared is equal to 3 squared plus 4 squared. So I know my Pythagorean triples. So I know that AB must be 5 then, mustn't it? Okay, so now AB is 5, so that's not equal to 6. So those two sides aren't equal. Let's have a look at the other side, QB. So what's QB? QB all squared. Again, going to look at the change in y. So that's, well, 5 minus 8, isn't it? It's uphill. All squared. Plus 4 minus 0. All squared. So 5 minus 8 is negative 3. Negative 3 squared is still 9. And 4 squared is still 16. And I'm going to get QB is equal to 5 as well. Okay, so those two are both 5. So that means that that side is equal to that side. And that means that I do have an isosceles triangle. So just need to write that down. So AB equals QB. So isosceles. Okay, good job. Question 6, y is inversely proportional to x, y is 0.04 when x is equal to 80, find the value of y when x is 32. This is a very straightforward proportionality question. I've been given the relationship between y and x here. So it says y is inversely proportional to x. So I can say y equal fishy 1 over x. Y is inversely proportional to 1 over x. So the next thing is to replace that sign of a proportionality with an equation and a constant. So y equals k over x. And look, handily they've given me two values that go together, and I can use those now to find out what k is. So when y is equal to 0.04, x is 80, so subbing those in, 0.04 is equal to k over 80. Okay, so then cross multiplying, I'm going to get 80 times 0.04 is equal to k. What's that then? 80 times 0.04 comes out to be 3.2, so k is 3.2. Okay, so once I know what k is, I can complete the equation then, can't I? So the entire equation then is going to be y is equal to 3.2 over x. That's my complete equation then, isn't it? Okay, right, so now I've got that, I can work out the next part of the question, which is find the value of y when x is 32. So when x equals 32, then y is going to be 3.2 over 32. That's super easy. Y is 0.1 then, isn't it? Okay, job done. So I just think these things are really easy to follow once you know how to do them, because they're always the same. They give you the relationship, they give you two pairs of numbers that you can use to find k, and then they give you a number that you then sub in to find the other number. Job done. Question 7. Edsel has 4 number cards, 3, 8, 9 and 12. Sharon has 3 number cards. U represents a number that Sharon knows. 11, 6 and U. Edsel and Sharon each pick one of their cards at random. They calculate the difference between the numbers on their cards. This is their sample space. Work out the values of R and T. So the numbers in the sample space then are the difference between the two numbers. So you can see the first number here, 6 and 3. The difference of 6 and 3, 6 subtract 3 is 3. Okay, so R is over here, look, so that's the difference between 9 and U, and T, which is here, look, is the difference between 12 and U. Now notice we've got these two other values in the U row. I've got 11 and 6, aren't I? So I know the difference between U and 3 is 11, and I know the difference between U and 8 is 6. So what must U be then, so that the difference between U and 3 is 11? Well, U is going to have to be bigger than 3, isn't it? Otherwise, well, it might be a negative number, I assume, but let's assume it isn't. So U is going to be 11 more than 3. That would make U 14 then, wouldn't it? Let's just double check that in the other one. If U is 14, then the difference between 14 and 8 is 6, so that would work in that one as well. It would work there and there. So I think U is 14. So now if I know that U is 14, so U is 14 here, then R is going to be the difference between 14 and 9. So R then is going to be 14 subtract 9, so that's 5. And T is going to be the difference between 14 and 12, isn't it? So 14 subtract 12, that's 2. So R is 5, T is 2. Question 8. The graph shows the speed of a tram as it travels from the library to the town hall. And we've got a little diagram underneath. It's a speed time graph, isn't it? So we've got speed in meters per second up the side, and I assume that's time along the bottom in seconds. Calculate the deceleration of the tram as it approaches the town hall. Okay, well, I assume that this upward part of the journey, that's it going from the library to the town hall. So you can see it's accelerating for all that period, and then it kind of reaches a peak speed, and then for the second part of the journey it's decelerating at a constant rate until it reaches a stop here. Okay, so calculate the deceleration part of the journey. Now on a speed time graph, acceleration is equal to the gradient of the line, isn't it? Now gradient is change in y divided by change in x, isn't it? In this case it's the change in the speed divided by the change in the time. So the speed changes from 6 down to 0 then, isn't it? So that's a change of -6 actually, because it's decreased. And the change in y is this distance from here to here, 85 subtract 65. Okay, which has got a difference of 20. So the acceleration is -6 over 20, which is -3 over 10, which is -0.3, equals -0.3. So if the acceleration is -0.3, then the deceleration is just 0.3, isn't it? Okay. because deceleration is how quickly it's slowing down, whereas acceleration is how quickly it's speeding up. So a negative acceleration means a positive deceleration. Right, part B. Calculate the distance travelled by the tram between the library and the town hall. Now, distance travelled is area under the speed time graph. Okay, and this case we've got two distinct areas, haven't we? We've got this one here, which is a triangle, and we've got a separate triangle here. Okay, so we've got two triangles. Another way of looking at it is those two triangles make one big triangle, don't they? So you can use the baseline all the way across from there to there, which is 85, and the height of the triangle is 6. So I'm just going to work it out as one big triangle, half baseline of 85 and a height of 6. So half 6 is 3 lots of 85, 240, 255. 255, and what's the units? It's in meters of second and seconds, so that's going to have to be meters then, isn't it? 255 meters. Part C says, what was the maximum speed of the tram as it travelled between the library and the town hall? Give your answers in kilometers per hour. Okay, so let's have another look at the graph. You can see from the graph its maximum speed is going to be that tip point on the graph, the highest point on the graph, isn't it? And we're already told what that is. That's 6 meters per second. So this question is just really about conversion, isn't it? We need to convert that 6 meters per second into kilometers per hour. Okay, so maximum speed is equal to 6 meters per second. So now we need to convert meters per second into kilometers per hour. Okay, now there are 1,000 meters in a kilometer. There are 60 seconds in 1 minute, and we've got 60 minutes in 1 hour, haven't we? So if we're going to convert this from meters per second into kilometers per hour, we're going to have to take that 6, divide it by 1,000 to go from meters into kilometers. We're also going to have to multiply it by 60 to go from seconds to minutes, and then multiply it by another 60 to go from minutes into hours. So what's that? Reaching for the trusty calculator. 6 times 60 times 60 divided by 1,000. That comes out to be 21.6. 21.6 kilometers per hour. Does that sound reasonable? Yep, it's not super fast, is it? It's probably what you'd expect a bus to be travelling at. Question 9. The graph of y equals x cubed minus 7x minus 12 is shown below. The roots of the equations x cubed minus 7x minus 12 equals 0 is p, and we need to calculate y when x is 3. Okay, so when x is 3, what's y? Y is going to be 3 cubed minus 7 lots of 3 minus 12, which is equal to, well, actually I'm not going to bother typing it in because this is a trial and improvement question. I can see that that's what it's kind of progressing into by looking at the next part down. So I'm going to use the table mode on my calculator instead. Okay, pull out the calculator. I've got the new 85 GTX version of the Casio calculator. When I click the menu button on here, I get 4 different options, and the one I'm after is the table mode, which is option 3. If you've got the older calculator, then it just says table. It's got some words in it, hasn't it? And you just pick the one that says table, which I think is also option 3. So anyway, I'm going to press option 3, and it gives me f of x is equal to. So this means what is my function of x, and I need to type it in. Now I've got a function of x here, x cubed minus 7x minus 12, and I'm going to type that into the calculator. Now you'll see that there's a little red X above the right bracket on this calculator. So to type in x cubed, I'm going to press alpha x to get that x up, and I'm going to press the cube button, x cubed. Then I've got right in minus 7x, so subtract 7. I'm going to press the alpha button again to pull up the x again, so minus 7x, and then minus 12 on the end. So that's my function x. It's x cubed minus 7x minus 12. Okay, when I press equals, it asks me for g of x. I don't want g of x, so I'm just going to press equals again. And then it asks me for a table range. I want to start on, well, I can see from my next part of the question that I'm interested in the range 3 to 4. And this part is looking at 3. So I'm just going to put in range 3 to 4 for now. So I'm going to start at 3, and then press equals, end at 4. And the step is how many steps you want to make between 3 and 4. I'm just going to make 1 for now. So I'm just going to have a little table with the numbers 3 and 4 in it. So on my display, you can see in the first column, I've got x, and it's showing me two values, 3 and 4. And in the next column along, it's giving me f of x, and that says minus 6 and 24. So they're my two values of y when x is firstly 3 and then when x is 4. Now we needed to calculate it when x was 3, so the answer is minus 6. Okay, now you could probably confirm that for yourself by cubing 3 and subtracting 7 lots of 3 and then subtracting 12, should get negative 6. Okay, but now I've got it set up in my calculator, I can carry on with this question. So in the part A, I already showed that when x is 3, then y was minus 6. Now the second answer on my table I worked out was when x was 4, and I know now that that is y is equal to 24 then. Now you'll notice from here to here, we've had a sign change, haven't we? Y has gone from negative 6, and now it's positive 24. So basically what we've done is we found a value here and a value up here, and when it changed signs, it's kind of crossed over, isn't it, between those 2 points. So P then is going to be lying somewhere between the two. Okay? So it's going to be when y is 0, isn't it? It's going to be somewhere between those two values. So to show that P lies between 3 and 4, well, we have done. We could just say what we've known then. So y has changed sign, so there must be a root between x equals 3 and x equals 4. Now, if you've got the older model of the Casio, this function should still work. It looks pretty much the same. Like I said, it just doesn't offer you the g of x option in the middle. You can still put the step in and the start value and the stop value, and it will still generate the table for you. Okay, let's move on. Part C says, find a smaller interval that contains the value of p. You must show your calculations to support your answer. Okay, so coming back to the calculator, when I set up this function earlier, I typed in work out the values between 3 and 4, and I told it to make a step of 1, so it stepped from 3 straight up to 4, so it just calculated those two values. Now if I press AC, it will pull back up the function I entered. Now if I press equals, it brings me to that g of x screen again. I'm still not going to put in a second function, and if I press it again, it takes me back to the start, end and step parts. So I'm going to go down and I'm going to change the step this time. So it's not 1 anymore. I'm going to make it 0.1. And what that will do is it will then create a table of values running from 3 to 4, going up in 0.1. So it will do 3, 3.1, 3.2, 3.3, 3.4, all the way up to 4. So let's press equals and see that in action. Okay, so if I press down, you can see all those different values. From 3.1 up to 4, and the corresponding values of f of x. Now what we're looking for is the sign change, where it goes from negative to positive. So you can see that happens here, doesn't it? At 3.2 it's negative, and at 3.3 it's positive. Okay, so all we're going to do is write down those two values. So we're going to write down when x is 3.2, y is minus 1.632, and when x is 3.3, then y is 0.837. So that tells me that p then has got to lie somewhere between those two values of x. Okay, because again, it's when it's equal to 0. So 3.2 was a bit too little, wasn't it? It came up to a negative number, and 3.3 is a bit too big. So the value of p is going to be somewhere between those two values. Okay, that's all we've got to do. So it's super easy if you've got a calculator and it's got this table function. Now the new Casio calculator is a stuff full of useful functions like this. So if you've not got one already, why not get yourself one for the exams? I've got this calculator recommended in my Amazon shop. So if you click on the link appearing on the card now, you can go straight there, or I'll put a link below if you want to find this calculator later. Highly recommend the 85 GTX that I'm featuring here. If you're thinking about going on to do A-level maths, you might want to think about investing a little bit more money and getting the FX991EX, and that will see you through your A-levels as well. I think it's probably about twice the price, but is good for A-level as well as GCSE. Okay, let's move on. Question 10. Two vectors A and B are shown on 1 centimeter grid below. Show that the vector A plus 2B has a length of 7 centimeters. You may use the grid below. Okay, so we've been given A and B graphically, so we've been shown them. So A plus 2B is going to be a vector A followed by 2 vector B's, isn't it? So let's draw those on. So vector A is 4 units along and 1 unit up, isn't it? So it looks like that. 4 units to the right and 1 up. So that's my vector A. And then vector B is this one up here, isn't it? So it's 2 to the left and 3 up. So 2 to the left and 3 up on my graph is going to be like that, isn't it? So that is vector B. But we're going to do 2 of those, so that's 1B, and a second B would then take me up to there, wouldn't it? So that's vector B followed by another vector B. Okay, now if I'd have gone straight from here to here, the resultant vector then is this straight line going between the two then, isn't it? So you can call this line here, this is the resultant vector A plus 2B then, isn't it? It's the one that takes us straight there. Okay, and you can see, well, I can just count 1, 2, 3, 4, 5, 6, 7. So it's of length 7. Question 11. The diagram below shows 2 triangles. Yes, it does. And it asks me to prove that triangle ABC is congruent to triangle ACD. Now, if 2 shapes are congruent, it means they have exactly the same shape and same size. Okay, but to show that 2 triangles are congruent, you don't have to prove absolutely every side is equal to each other. There's some minimum conditions that you can prove, and if you can prove those, you can say that the 2 triangles are definitely congruent. And they've got like little handy initials to help you remember them. They are RHS, right angle hypotenuse side. So if you can show that your 2 triangles have both got a right angle, the hypotenuse is the same length and one other side is the same length, that is enough to state that the 2 triangles are identical. And then you've got the side, side, side rule. So if you can show all 3 sides are the same, you can say they're definitely the same shape and size. There's the SAS rule, side, angle, side. So 2 sides and an included angle. If you can find those in both triangles are the same, you can state they are definitely congruent. And then finally, you have ASA, 2 angles and included side. Now looking at my diagram here, you can see that I've been given mostly angles and no information about sides, although I can see that one side is shared and they have that side AC in common. Okay, so that's what I'm going to be using today. I'm going to be looking at the ASA. I'm going to try and prove that two angles are the same and the included side is the same. Okay, so we're going to try and prove these two triangles are congruent using ASA. Now we can already see this side here, the side AC, that's a common edge, isn't it, to both triangles. So it's clearly the same length because it's the same line. So we can say in triangle ABC versus triangle ACD, then my length AC is going to be equal to my length AC. Okay, so that's one thing. That's the side part, isn't it? Now we need to show that the angles either side are the same. So I've got some missing angles here, haven't I? So what's this one up here? This one is going to be 180 minus the other two, 80 plus 44. So 80 plus 44 is 124. 180 minus 124, that is equal to 56. Okay, so that angle is 56. And similarly, this one here is going to be 180 minus the other two, 80 plus 56. And so that one's going to be equal to 44, isn't it? Okay, so we know that AC is equal to AC. Now let's show the angles either side then are the same. So we're going to say that this one here is the same as that one. 56 is the same as 56. How are we going to write that down? We're going to say that angle BAC is equal to angle ACD, which is 56. And we know that the other angle, so this one over here is 44 and this one is 44. So we can say that angle ACB is equal to angle DAC, and that is equal to 44 degrees. So therefore triangles are congruent, and the reason is ASA. There we go, job done. Question 12. The diagram below shows two right-angled triangles. I've got QRS and I've got PQS, and I need to prove that PQS and QRS are similar. Now if two triangles are similar, either all their angles are the same, so if I can show that that angle is the same as that angle and that angle is the same as that angle, then we've got two similar triangles. Or I could show that the sides are in the same ratio, which might be a little bit harder to do here because I haven't got all the sides. Well, I suppose I could work out all the sides, couldn't I? So that's what I can do. I can either work out all the sides using Pythagoras theorem, or I can work out the angles using trigonometry. I think I'm tempted to find the angles, because if I find the sides, I don't know. I think they might be not very nice ones looking at the triangle. They might be surds. So I think I'm going to go for angles. Right, so let's have a look at this first angle here. I think we're going to work on triangle QRS first, because I know most about that one. I've got two sides, haven't I? So if I know two sides, I can find all the angles, no problem. So let's do that. Let's use SOHCAHTOA then in this triangle. So let's say in triangle QRS, which is this one up here, look. What do we know? We've got right angle, we've got, so let's find the angle down here, the blue one first. So what's that angle there? Let's call it theta. Okay, so if that's theta, then opposite that is the 8 and adjacent to that is the 4. So what's our mnemonic for trigonometry? SOHCAHTOA? Is that what you use as well? SOHCAHTOA? So looking at that, which ratio has got to do with the opposite and the adjacent? It's this one, tan. Tan is equal to opposite over adjacent. So I know that the tan of my angle is equal to the opposite over the adjacent. So in this case, the opposite is 8 and the adjacent is 4. So what's 8 over 4? That's 2, isn't it? So inverse tangent of 2, what's that going to give me? So shift tan 2, and that's equal to 63.4 and change, isn't it? Okay, and then, right, now if I want to do something similar in the other triangle, in triangle PQS, the problem is I've only got one side so far, haven't I? I've got the 10. So I need to find another piece of information about this triangle before I proceed. So again, similar to the last question, these two triangles share a common side here. So if I can work out that length of my first triangle, it's going to be the same as the side in my second triangle, isn't it? So that's what I'm going to do. I'm going to find length QS. So QS squared. I'm going to use that Pythagoras theorem, isn't it? It's the longest side of that top right angle triangle. So it's going to be QS squared is equal to 4 squared plus 8 squared, isn't it? 4 squared is 16, 8 squared is 64. Add them together, you get 80. So then QS then is going to be root 80. Okay, so QS is root 80. So now I can use trigonometry in the second triangle, PQS. I'm going to find that same angle down here, this angle here, angle P. Okay, so again, so if that's the angle I'm trying to find, then 10 is the hypotenuse, isn't it? So I've got the hypotenuse this side, and the root 80 is the opposite. So this time I'm going to be using sine. Sine is equal to opposite over hypotenuse. So sine of my angle, well, it's angle P, and that is equal to the opposite over the hypotenuse, which is root 80 over 10. Okay, so then P is going to be the inverse sine of that then, isn't it? So shift sine root 80 over 10. Now look, it's come out to be the same thing. It's 63.4. Okay, so again we got to the point now that I think we can say that they are similar then. So we just equate the things that are the same to each other. So we've got triangle PQS and triangle QRS, haven't we? So let's equate like with like. So let's equate the right angles first. So I've got QRS in the first triangle, and that is equal to PQS in the second triangle, which is equal to 90. And then I've got the ones we found, so that's the angle at Q then, isn't it? So that would be angle RQS, and that is going to be the same thing as angle QPS, and we found that to be 63.4. And the other angle, well, they've got to be equal as well, haven't they? Because if we found two angles are the same, the other one is going to be the same because we'd find them the same way, wouldn't we? So we can just state that those two are the same. So what's that? That's QSR. That's got to be equal to PSQ. I didn't actually calculate it, but I don't think I need to. Okay, because it's self-evident from the other two. So I've shown that my three angles are equal, and therefore triangles are similar. Question 13a, calculate the volume of a sphere with radius 6 centimeters, and I've been handily given the formula. V equals 4/3 pi r cubed, although I do recommend you just know these anyway, they're handy to know. So the volume, just need to sub the r in, don't we, and it's job done. So 4/3 pi r cubed, which is 6 cubed. So 4/3 pi 6 cubed. What's that then? Let's tap that into the calculator and find out. So 4/3 of pi times 6 to the power of 3. That comes out to be 288 pi. Suppose we should put that as a decimal. So it's 904.77. I'm going to round that off to 3 significant figures, which is 905. Radius was in centimeters, so this is centimeters cubed, isn't it? 905 cubic centimeters. Part B says an ornament is made from a solid glass square base pyramid. The base has side length 15 centimeters. A hemisphere with radius 6 centimeters is cut out of the base of the pyramid. This reduces the volume of the glass contained in the ornament by 30%. Calculate the perpendicular height of the pyramid. We've handily been given the volume of a pyramid formula, which is 1/3 of the area of its base times its perpendicular height. Oh, and it's telling us that a hemisphere is half a sphere, if we didn't already know that. Okay, so notice this is the same size sphere or hemisphere as we had in the first question, and we worked out that the volume of that was 288 pi for a whole sphere. So that half sphere that has been drilled out is going to be half of that then, isn't it? So I'm just going to write that down first off. So the volume of the hemisphere is going to be 288 pi over 2. So what's that? 144 pi. I'm going to just leave it like that because I'm sure I'm going to need it again in a minute. Right, what else do we know? So when we drilled that out, then the volume of the glass contained in the ornament was reduced by 30%. So this 144 pi must be 30% of the whole pyramid. Make sense? Must be, mustn't it? So it was 100% to start with. We drilled out that hemisphere and it's now 30% less. That means that this is 30% of the pyramid. Okay, so what is the volume of the pyramid then? So that the volume of the pyramid then is going to have to be what if 144 pi is 30%, if I take that 144 pi and I divide it by 30 and I times it by 100, I'll get 100%, won't I? So let's do that. 144, I'm not going to bother putting the pi in because I'm just going to use it as a multiplier of it. So that comes out to be 480. 144 divided by 30 times 100, so that's 480 pi. Okay, so that must be the volume of the pyramid, 480 pi. But we also know that the volume of a pyramid is 1/3 times the area of its base times its height. So what is the area of base? So it's a 15 centimeter square, isn't it? I'm told it's a square base pyramid. So the area of the base is 15 squared. What's that? 15 squared is 15 times 15, 225. Okay, so the area base is 225, the volume is 480 pi. So we should be able to then work out what the perpendicular height is then. So now using the volume of the pyramid is 1/3 times the area of the base times the height. We know everything in there bar the height, don't we? So we know that the volume is 480 pi. 1/3 is 1/3. The area of the base is 225, and our height h is what we're trying to find, isn't it? Okay, so let's rearrange for h. So then h then is going to be 480 pi times 3 divide by 225. Time for the calculator. So 480 pi times 3 divide by 225. That comes out to be 32 pi over 5, which is 20.1. So I'm just going to round off to 3 significant figures. So that's 20.1. I suppose it's in centimetres, isn't it? 20.1 centimetres. Lovely job. Question 14a. Standard bricks have dimensions 21.5 centimetres by 10.3 centimetres by 6 centimetres. Correct to 1 decimal place. A house is built using 4,663 standard bricks. Jocelyn says, placed end to end, those bricks from the house would definitely reach over a kilometre. Show that Jocelyn's statement is correct. Okay, so let's just have a little think about the brick to start with. Bricks tend to be cuboids, don't they? So it's got the long measurement along here. That was 21.5. And then 10.3 is one of the other ones. I'm going to assume it's the depth, and I'm going to assume the height of this is 6. Okay, so if we're going to arrange these from end to end, they're going to stretch the furthest if I put them lengthways, and aren't I? So I don't need to use all of these measurements. I just need to use one of them, which is this measurement here, 21.5. So I'm going to have 21.5, 21.5, 21.5 for each of my 4,663 standard bricks, except that I'm told up here that these distances are correct to 1 decimal place, which means that they might not be exactly 21.5 centimeters. Now, when I've been given a range, this is like an error interval that we need to calculate with here, isn't it? So what I tend to do is draw a number line. So here's my number line. I'm going to mark on the number they gave me, 21.5. And I'm going to go correct to 1 decimal place. So that's like a decimal point either side of that on my scale would be, the next one up would be 21.6, and the one below would be 21.4. So all the numbers that are correct to 1 decimal place and round to 21.5 are all the numbers which are halfway between there and there, and halfway between there and there, or nearer. So all the values in here in this range round to 21.5. They're a bit bigger than that, they'd round up to 21.6. If they're a bit smaller than that, they'd round down to 21.4. So what is halfway between 21.4 and 21.5? This is what we call the lower bound, and that would be 21.45, halfway between the two. And the upper bound is going to be halfway between 21.5 and 21.6, and that is 21.55. Now, strictly speaking, that would round up to 21.6, wouldn't it, if you were rounding off 21.55? But it still is the boundary, and it's still the one that we use in these sort of calculations. Right, so that is the value. So placed end to end, the bricks of this house would definitely reach over 1 kilometre. To be definite about it, let's take the worst case scenario, that these bricks are at its lower end. Obviously, if I take the upper end, it's going to be longer, isn't it? So there's more chance of it being over a kilometre at this end, at the larger end. So just to make sure, I'm going to pick out the smaller end and use that in my calculation. So if I take, so the minimum length that this line can be is, the length it would be then would be my 4,663 bricks times by the lower bound, 21.45. Okay, calculator, what is that? 4,663 times 21.45. Well, that comes out to be 100,021, doesn't it? And change 0.35. Okay, so that's in centimeters, isn't it? So if I want to convert into kilometers, I've got 100 centimeters in a meter. So divide that by 100 to get meters. and there are 1,000 meters in a kilometer, so divide it by another 1,000 to get kilometers. So I'm going to take my answer, divide it by 100 and divide it by 1,000, and that's going to come out to be 1.0002135. kilometers. Now, because we took the lower bound, that was the smallest possible length of this, most likely these bricks are going to be longer than that, and so we can say that it will definitely reach over. So we can say that yes, she is correct. Part B says a standard brick should weigh 2.8 kilograms, correct to 1 decimal place. A truck can carry a maximum load of 20 tons. Calculate the maximum number of standard bricks that the truck should be able to carry. Okay, so again, we've been given this number correct to 1 decimal place. I'm going to take the same approach as I did last time. I'm going to draw a number line, I'm going to mark on the number they gave me, which is 2.8. I'm going to mark 1 up on the scale, 2.9, I'm going to mark 1 down on the scale, 2.7. And I'm going to work out what's halfway between those. So this is my range of values then, around 2.8. Halfway between 2.7 and 2.8 is 2.75, and halfway between 2.8 and 2.9 is 2.85. So that is my my range of values that round to 2.8. Just bring that down a little bit. I don't know if it went off the top of the page. Calculate the maximum number of standard bricks that the truck should be able to carry then. So let's take the worst case scenario and imagine that the bricks are at the heavier end. Okay, obviously if the bricks are heavier, then the truck will be able to carry fewer of them than if they were lighter. So I'm going to take the heavy end of the bricks, 2.85, and I'm going to see how many of those I can fit into 20 tons. Now 20 tons, a ton, 1 ton is 1,000 kilograms, isn't it? Okay. So 20 tons, that's 20,000 kg. Okay, so I've got 20,000 kg, and I know that 1 brick is 2.85 at its heavy end. So let's do number of bricks. That's going to be my 20,000 load divided by the weight of a brick, which is 2.85 in its worst case scenario. Okay, so let's tap that into the calculator. 20,000 divided by 2.85. So that comes out to be 7,017.5. Okay, in this case I'm going to round down, because I don't want a bit of a brick, that's no good, so I'm going to round down to 7,017. Okay, right, part 2 says, explain why your answer to part 1 may not be possible to achieve. Okay, so we know that it can definitely hold the weight of these bricks, but just because it can hold the weight doesn't mean it can take all those bricks, because they might not be able to physically fit into the loading bay of the truck. So we know it can take the weight, but we don't know it can take the size of the brick. So it might just physically take up too much volume to fit into the space. So that's what I'm going to write down. So may not be able to take the volume of bricks. Okay, so it can take the weight, but it might not be able to take the size. Question 15. Ratner invests £1,200 for 2 years in a bank account paying R% per year compound interest. At the end of 2 years, the amount in the bank account is £1,379 and 2 pence, and we need to calculate R. Okay, so now normally in a compound interest question, we would work out our final amount by taking the original amount, timesing it by the multiplier, which would be you know, if it was 5% interest, it would be 100 plus 5, or 1.05 as the multiplier, raised to the number of years. Okay, now in this case, we know some of these values, but not all. We know the final amount was 1379.02. We know the original amount, it was 1,200. We don't know the multiplier. I'm just going to call it M for now. It's not quite the same thing as R. And then years we know is 2. Okay. Right, so what is M then, the multiplier? Okay, so if I want to get M by itself, I would have to cross multiply that 1,200. So that would give me 1379.02 over 1200. And then I'd need to square root, wouldn't I? Okay, and that's going to give me M. Okay, so let's work that out. 1379.02 divided by 1,200 and then square rooted. That comes out to be 1.07199999, which I'm going to round off to 1.072. So M equals 1.072. Now that is the same thing as 107.2%. So R is going to be, because you start off with 100%, so if then we've got 107.2%, we must have had an interest rate of 7.2%. Okay, so that's what R is, 7.2%. Question 16, the box plot shows the distribution of salaries for the workers at Bexbridge Biscuits. And we've got a box plot. Okay, so when you've got a box plot, the lower line here, this is Q1, this is the lower quartile. The line in the middle is Q2, also known as the median, and this one up here is Q3, the upper quartile. The whiskers then go out to the highest value in your data set up this end, and the lowest value in your data set down this end. Okay, so what is the median salary? The median then is Q2, it's this value here. So all we've got to do really is read off this value from our graph. Okay, so just reading down, you can see it's here on our scale. So what's that? This scale is 30,000 to 40,000, and I've got 10 divisions in between. So each one of those divisions is going to be 1,000, isn't it? So I make that 30, 31, 32, 33, 34, 35, 36, 37,000. So I think the median salary here is 37,000. Okay. Interquartile range is Q3, the upper quartile, minus Q1, the lower quartile. Okay, so I already pointed those out. So Q3 is this one up here, and Q1 is this one down here, isn't it? So Q3 on our scale, what's that? That's 43,000. And then Q1 is down here, that's at 21,000. Okay, then subtract one from the other, and that is your interquartile range. 43,000, subtract 21,000, that's £22,000. Okay, put a pound sign in. Okay, so that's the median and the interquartile range. Okay, part C, the following salary information is true for workers at Camford Cookies. So this must be some sort of dastardly rival to Bexford Biscuits. So what do we know about Camford Cookies? The highest paid worker earns 85,000. The lowest paid worker earns 20% of the salary of the highest paid worker. 25% of the workers earn more than £50,000. 25% of the workers earn less than £28,000. The median salary is £37,000. Okay, that should be enough information to work out our box plot then. You remember we needed to know 5 values, didn't we? We needed to know We needed to know the Q1, the Q2 and the Q3 values for doing the box, and we needed the highest and the lowest to do the whiskers. So we know the highest, it's here. So that's the first value, 85,000. So that's going to be what we're going to have up this end, 85. Now the lowest paid worker earns 20% of the salary of the highest paid worker. So that's going to be what, 0.2 lots of 85,000. So 10% would be 8,500. Double that is 17,000, isn't it? So the lower end is going to be 17k. And then what is our Q1? 25% of workers earn more than 50,000. Well, 25% down from the top. That they're actually talking about the upper quartile there, aren't they? So this one here is at 50k. And 25% of the workers earn less than 28,000. That's going to be my lower quartile, so that's 28k. And the median salary is 37. Okay, so we've got all the values now that we need to plot. It's a good idea to work them all out first, and then you can draw your box plot with confidence then, aren't you, that you know all the answers. Okay, so let's mark those values on first. So the lower value was at 17,000. So 17,000, that's 20, 19, 18, 17 is there. Okay, so that's my lower quartile. No, sorry, my lowest value. My lower quartile, we said, was at 28,000. So 30, 29, 28 is there. Then we had a median at 37,000. 40, 39, 38, 37. And then we had the upper quartile at 50,000. Nice, easy one to draw. And then we've got the highest value at 85, the fat cat there at the top. So 81, 82, 83, 84, 85, it's that one. Okay, so now I've drawn all the lines, I can form a box in the middle. And then I can draw my whiskers going out to my highest and lowest value. Okay, that'll do. Looks pretty good. Part D says, make two different comparisons between the distributions of the salaries at Bexbridge Biscuits and the salaries at Camford Cookies. Okay, now if I pull up both of the box plots that we've done, or the one that was given and the one that we've drawn, now whilst these distributions are clearly different, they do share a number of similarities. Firstly, they have the same median. It's £37,000. That's the same for both. And also, if you look at the interquartile ranges, they are both the same width as well. They're kind of in a different place, but they have the same width. So the upper bound, so the upper quartile subtract the lower quartile, and both of these gives you the same answer of 22,000. So whilst they are clearly different distributions, I'm going to write down what's similar about them actually, because I'm going to compare the interquartile range and the medians. So let's do the interquartile range first. So the interquartile range is 22,000 for both distributions. Indicating that the spread of salaries is similar, and I'm going to say the average salary in both companies is the same. So, and median equals 37,000. Okay, so the interquartile range is 22,000 for both distributions, indicating that the spread of salaries is similar, and the average salary for both companies is the same. Median is 37,000. Question 17. Here is a function. I've got function A. We've got an input, and then we add 14 and then times by 5 to get the output. It says the output of function A is x. Write an algebraic expression in terms of x for the input of the function A. Okay, that's quite unusual. Normally we say that x is the input. Now, we've just tried to turn things around a little bit here to try and confuse us. So if the output is x, so let's work backwards and find what we put in if we got x out. Okay, so if we had x come out, working backwards, so going kind of backwards through this function machine, at this point here, what must have I had so that when I times it by 5 I've got x? Well, I would have had to had x over 5, wouldn't I? A fifth of x. So when I times it by x, I would have got x back again. And then going backwards through the first box, that plus 14 box, in what would I have to add on to get x over 5? I must have had x over 5 subtract 14, so that when I added the 14 it would cancel out, leaving me with x over 5, and then when I multiplied by 5 I would end up with x. So basically what we're doing here is we're finding the inverse function, aren't we? We've worked out what the inverse function of x is. So what is the expression we would get? We would get x over 5 minus 14. Okay? B, a number k is also input into function A. The output is also k. Find the value of k. Well, that's interesting. So if I take k and I feed it into this function machine, then after the first box I'm going to get k plus 14, and then after the second box I'm going to get 5 lots of k plus 14, aren't I? And what they're saying here is that the output must be the same as the input, so that must be equal to k. Okay, so I've got now an equation that I need to try in k that I need to try and solve, haven't I? So if I've got 5 lots of k plus 14 is equal to k, right, let's just first remove that bracket. So 5 times k is 5k, and 5 times 14, that's 70, isn't it? That must be equal to k. So then subtracting k from both sides, don't know why that came out in blue. What am I going to get? So that's going to cancel, leave me with 0. So I'm going to 5k minus k, that's 4k. So 4k plus 70 is equal to 0. Subtracting 70 from both sides, I'm going to get 4k is negative 70. And then dividing through by 4, what's that? Half is 35, half again is 17.5. K is negative 17.5. Okay, I think that's it, isn't it? So if I put k is negative, if I put negative 17.5 into this function machine, then negative 17.5 should come out again the other side. You could just double check that, just feed it through, add 14 to it, times it by 5 and see if you get negative 17.5 back again. Question 18. Percy sells paint in standard tins and large tins. The standard tin covers 40 square meters and the large tins covers 60 square meters. Question A says, Percy publishes this chart showing the area that can be covered with each tin of paint. Explain why the chart is misleading. Okay, so this is a bar chart, isn't it, he's drawn, but I don't know if you can see, but they've got different widths. So this one is narrower than this one. Okay, so I'm going to say that the bars have different widths. Part B says the standard tin and the large tin are mathematically similar. The volume of the large tin is 50% more than the volume of the standard tin. Both tins are cylinders. The radius of the standard tin is 10 centimeters. Calculate the radius of the large tin. Okay, so I'm just going to quickly sketch this because it's a shape and space question and there is no sketch. So, standard tin. What do we know about standard tin? We know that the radius is 10 and we know that the volume, well, we don't, let's call the volume 1 volume, and then we've got the mathematically similar second tin, larger tin. Now this one we want to find its radius, but we know that the volume of this tin is 50% more than the standard tin. So if that first tin was 1 volume, then this one is going to be 1.5 volume, then, isn't it? It's going to be twice, well, half as big again. Okay. Now, ratios of lengths, areas, and volumes are related to each other, aren't they? Okay. If you know ratio of lengths, let's say to x and y, then the ratio of their areas is going to be x squared to y squared, and the ratio of their volumes is going to be x cubed to y cubed, isn't it? Okay, so we know that their volumes here are 1 to 1.5. So to find the ratio of their lengths, then we're going to have to cube root these. We're going to have to find the cube root of 1 and 1.5. Well, the cube root of 1 and 1.5 is pretty easy. Cube root of 1 is just 1. But what is the cube root of 1.5? I don't think that is an easy number. Let's pull up a calculator and find out. Cube root of 1.5 comes out to be 1.1447. Okay, so this should be in the ratio of 1 to 1.1447. Okay, I'll just write the first few digits down for now. I'm probably just going to use the calculator value anyway. Okay, so if you know that's the ratio of their lengths, then the radius for the larger tin, then the radius is going to be the radius of the smaller tin, 10 times the cube root then of 1.5. I'm just going to write it down like that because it's a bit more precise. So then I'm going to take my calculator stored value that I just had, I'm going to times it by 10, and that should tell me the radius of the big tin. So that comes out to be 11.447. I'm going to round that off to 11.4 centimeters. Okay. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 90. Show that 2x squared plus 13x plus 20 over 2x squared plus x minus 10 simplifies down to x plus a over x minus b, where a and b are integers. Okay, this looks fun. So basically we're going to have to factorize these two quadratic expressions, aren't we? And then hope that we've got a common factor in both that's going to cancel away and just leave us what we've got there. That's the plan. So slightly complicated by the fact that we've got a coefficient of x squared here of 2. Just makes factorizing a little bit more fun, doesn't it? Okay, so let's have a look at the top one. This has got a last number of plus 20. Everything's positive here, so it's going to factorize down to 2 brackets. It's going to have a 2x and an x, giving me my 2x squared. Everything is positive, so it's going to be plus and plus. And what are the factor pairs of 20? Well, what have we got? Factor pairs of 20 could be 1 and 20, 2 and 10, 4 and 5. So these are all possible pairings to go inside this bracket here. We're aiming for 13 in the middle, so we want two of these that add up to 13. Now remember, the one that we put in this side in here is going to get multiplied by the 2x, so its contribution towards the middle term is doubled. So I'm thinking it must be this pair, because if I double up 4, I'm going to get 8, and then if I add on the 5, I'm going to get 13. So that's how that top one is going to work then. So if I put the 4 in here, so 2x times 4 is 8x, and x times 5 is 5x, and 5x and 8x must make 13x. Okay, so I factorized the top part of this quotient. Let's have a look at the bottom part now. So again, I've got a 2x at the beginning, a 2x squared, sorry, at the beginning. So that means I'm going to have another 2x and an x. At the end this time, I've got minus 10, haven't I? Okay, so I'm looking for factor pairs of 10. So what are the factor pairs of 10? 10 has factor pairs 1 and 10, 2 and 5. Okay, now I'm feeling it's got to cancel with that first one, so I'm thinking it's probably going to be this one here with the 5 in here, isn't it? I'm thinking it's going to be plus 5 minus 2. Let's just double check that is true. So I've got the 5 times x would be 5x, 2x times minus 2 would be minus 4, and 5x take away 4x would be x. So that is right, isn't it? So that's the way around it does go. Okay, so it's going to be 2x plus 5, 2x minus 2. Okay, and now you can see that we can cancel those first two brackets away from each other. They're going to cancel each other out, top and bottom. So it's just going to leave me with the x plus 4 on the top and the x minus 2 on the bottom. So we've simplified it to x plus 4, x minus 2, where 4 and minus 2 are both integers. Yes, they are. So that's good, isn't it? We've done it. That was quite easy for our last question. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.